All right. So for us to be able to deploy our application to Kubernetes, we actually need to Dockerize our application or put it in a specific container. So for the most part, what I'm simply going to do is I'm not going to use the Spring Native that was generated here. What I'm simply going to do is I'm simply going to prepare a Docker file that we can actually go ahead and use to deploy our application. So in this case, I'm going to create a file called Docker file. I'm just going to say .native. So once you have created the Docker file, what I'm simply going to do, I'm simply going to paste some Docker commands that I have here. So for the most part, what I've done here is I'm going to use my Docker file as a multi-stage Docker file. So it will have a builder from that imports from the base from GraalVM using Java 17. And this is the builder, and then I'm going to install some Maven binaries using this command. And then once I install these Maven binaries, what I'm simply going to do is, as an argument, I'm going to pass the root so that I'll be able to download these further Maven download, right? Because I want to download the Maven binaries, right? So I'll put the keyword. So if you visit this link, you'll see all this information, including the SHA key, right? So once I've done this, I'll simply create some couple of directories, and then I'll download the Maven binaries, and then I'll simply extract them and then move them to different folders. I'm not going to go much deeper into this. Then I'm going to create a working directory called build, and then I'll simply copy the code into this build. Then once I copy this code, what I'm going to do here, I'm simply going to run the Maven command, right? So remember that clean package pnative, because you want to be able to generate this Spring executable inside our Docker, right? So what I'm simply going to do is I'm simply going to build this using that command that we're running. And then once I've done that, I will then now build net or run the native executable from the Oracle Linux Slim. So since this is a multi-stage build, right? So the first one is just to build the native executable, right? And then the second one is now sort of like to build the deployment image, right? So in this case, I'm simply going to expose the port 8080, and then I'm simply going to run the build target, then the Spring Native. So here you might need to actually rename depending on the name of a project. So mine is Spring Native. So I'm simply going to run it, and then this is going to be my entry point. Right, so in this case, I'll run this Spring Native that would have been generated. So after you've prepared your Docker file, we now want to test this Docker file. So we need to build an image out of this Docker file. So what I'm simply going to do is I'm simply going to use the docker build command. So I'm simply going to say docker build. So in this case, I'm going to use my Docker file as a reference. And then in this case, what I'm simply going to do is I'm simply going to tag my image with a Spring. So I can say Spring, and then maybe my native as a tag, and then I will reference the current directory, right? Here's my path. So in this case, so if I run this command, what I'm expecting, so there's an error. So here I didn't need to say IT, I just need to take the image. Right. So what this does is it will actually build a native image out of this Docker file. All right. So now that our build has finished building, if you actually go ahead and check the images that were generated, you can actually see that we now have, was it my native? This one. So we now have our Spring my native image that was generated from the Docker file. So to run it, you simply run the docker run image command, but in this case, it's now Spring my native. Then you can always take it to the latest. So if you run this image, you can actually see that this was also a native executable which ran in less than 100 milliseconds. Yeah. 161 milliseconds. So for the most part, you can actually see that this is how you actually go ahead and create a Docker file which is multi-stage, so which means the Docker file will be small, right? So yeah, it will be small. So in this case, yeah, it's around 191 megabytes in terms of the image size itself. So in the next section, we're simply going to look at how we can actually go ahead and deploy this Docker image to our Kubernetes cluster. So to deploy our application to Kubernetes cluster, in this case, I'm simply going to use Minikube. So you need to make sure that you install Minikube. So if you're on Mac OS, you simply need to run brew install Minikube, and then you press enter. So in this case, I'm not going to run it because I already have Minikube running. Then the next thing that you need to run is you need to install a hypervisor virtual machine that you actually run your Minikube with. So in this case, I think I'm using, so if you say brew install hyperkit, so in this case, I'm using hyperkit. So you can say brew install hyperkit. I'll put the installation links down in the description, but you can always install any hypervisor of your choice. So in this case, I'm using hyperkit. So once you have the hypervisor and the hyperkit installed, we now want to start our Minikube. So to start our Minikube, I'm simply going to say Minikube start. Right, in this case, I need I can actually go ahead and specify the driver, the hypervisor driver that I'm using. So in this case, I'm using hyperkit, and since we're going to be building our native executables inside the Minikube cluster, we need to make sure that we provide it with enough resources for it to be able to spin up pods for the most part. So in this case, I think I'm going to give it maybe a memory of 8 gig, and in terms of the CPUs, let's say I'm going to give it, let's say 4 CPUs, right? So just depends with the specs that we have. You can always adjust this, but for the most part, I wouldn't want anything to fail. So in this case, I'm just going to give it 8 gig of memory. Right, so for the most part, it's actually starting our Minikube cluster with this memory allocation that we've provided it. All right, so once your Minikube cluster you have successfully installed, you can actually check the resources. So if I say kubectl get namespaces, right, you can actually see that I have the default kubectl, the default namespace, right? So the next thing that I want to do is I want to install our Istio, which we're going to use as our Ingress gateway, right? So for the most part, Istio is just an open source implementation of a service mesh, right? So I'm planning to do more videos on Kubernetes and Istio. So for the most part, I'm not going to dive deep into Istio, but for the most part, just know that Istio, we're going to use it to inject our envoy proxies, which will be able sort of like to establish communication between our microservices, as well as, you know, establish our gateway, our Ingress gateway, and also our virtual services. So in terms of that communication, for us to be able to access our service from outside, we're going to be using Istio. So to install Istio, it's fairly simple. So what you simply need to do is you can navigate. So let me just open a new terminal, and I need to navigate to my root folder. So what you simply want to do is you simply want to download the Istio zip or the Istio folder. So the way we're going to download the Istio folder is by simply typing this curl command. So I'm going to put the links in the description down below. So you need to curl this, right? Then once, so I'm not going to download because I've already downloaded. So once you download, you need to navigate to the Istio folder that you would have downloaded. So if you open this extracted Istio folder, you actually see that you have a couple of things, including the bin folder. So what we simply want to do is we want to be able to use Istio CTO, because for you to be able to install Istio, you need to use Istio CTO to do that. The next thing that you want to do is you want to be able to expose this bin to your path for your path variable, so that you'll be able to use the Istio CTO. So once you've done that, now we can actually go ahead and use the Istio CTO to install our Istio in our Kubernetes Minikube cluster. So to install, you simply type Istio CTO install, then set, then profile demo, and then you can accept all agreements, right? So what this does is it will install our Istio in our Minikube cluster. All right, so once Istio is successfully installed, let's just jump into our Spring Native folder. To check it, you can simply say kubectl. If you say get namespaces again, you should be able to see that you now have a new namespace that was created 102 seconds ago, which is called Istio system, right? So if I want to view or to see everything that is in this Istio namespace, I'll just say kubectl get all. Then I'll say I'll define the namespace that I want to view things, right? So for the most part, you can actually see that we have our pod, our Istio pod, which has the Egress and the Ingress gateway. I'll explain what this is shortly. Then we have our Istio service, as well as the Istio D, as well as same applies on the pod as well. We have the Istio D, which is our control plane, and we also have the replica sets for both the Ingress and the Egress gateway. Right, so what these things are, right, is the Istio D. So for example, if you check our running pods, we have 3 of them, right? So first of all, we have the Istio D. So what the Istio D is, this is our control plane, right? So this is our control plane that's sort of like our brain to the main Istio system, or in terms of how our service mesh is going to work. So inside this Istio D, we have something that's called a pilot, a citadel, and also a gallery. Right, so what these things does, it will allow Istio to be able to control things that will happen within our Istio system, right? So I will do a separate tutorial about Istio. So we have something that is called the Ingress gateway. So the Ingress gateway is responsible for controlling traffic. So all requests or traffic that will be coming into our cluster, they're going to be routed via the Ingress gateway. Then the Egress gateway is responsible for the traffic that will be leaving outside of our Kubernetes cluster. So the Egress gateway is actually responsible for that. Then same applies. You can actually see that. So all these 3 pods, they're also available for the pod, the services. So as you can see, for our Istio Ingress gateway, so the Ingress gateway is the one that we're going to configure to allow incoming traffic to our cluster. So we need to configure it via, if we create our own gateway, we need to point to this default Ingress gateway. And if you can actually see that the type is actually a load balancer, right? Which means it should have a public IP. So in this case, it's saying pending right now because this is just a Minikube cluster. So our virtual machine doesn't have a public IP. But if it was on an actual cloud, you'd actually see that it would have automatically assigned an external IP here via our node. But for the most part, this would just say pending. So we'll demonstrate how we can port forward so that we'll be able to push traffic via this. So this will be our load balancer. Then the Istio D, these are internal services, and as well as the Egress. So by default, they are cluster IPs, which means you can't access them from outside. So for the most part, just in summary, just know that we have our control plane, which is called Istio D, which also comes with the Egress for exiting traffic, and the Ingress for internal traffic. So for the most part, this is how it sort of look like. So once you have created, installed your Istio, you can actually go ahead and create our Kubernetes resource. So the first thing that we need to do is we need to create the namespace for our backend service, right? So I'm going to say kubectl create namespace, right? So the namespace, I'm simply going to call it, let's say backend services, right? So if I check kubectl get namespace, you can actually see that we have created a namespace that is called backend services, right? And then once you have created this namespace, right, what we want to do is we want Istio to be able to inject the envoy proxies, right? So what are these envoy proxies? So basically the envoy proxies, what they do is they remove the headache of us configuring things like security, communication between microservices, so there's security, communication, and other things that it also comes with, that allows us not to sort of like do it ourselves within the microservice. Because for the most part, if you're writing a microservice, you simply want to keep your business logic to the microservice. So you don't want to worry much about security, how we are going to handle security, how we are going to handle communication within your services. So you want to be able to, we want Istio to be able to use these envoy proxies to do that configuration for you, right? So for us to be able to do that, right, we need to actually inject something that is called Istio injection to our namespace, right? So for us to be able to do that, right, so let's see. So if you want to check the labels that are associated to your namespace, you simply say kubectl get namespace, right, and then you can say backend services, and then I can say show labels like so, right? So for the most part, you can actually see that we only have one label which comes by default, which is the Kubernetes IO, which is injected to our backend service. So for us to be able to inject, like I said, to inject the sidecar envoy proxies to our namespace, so that every time we create a pod inside our namespace, we want Istio to be able to automatically inject these envoy proxies. To be able to do that, we simply type kubectl, then you say label, so you use the label command, right? So again, like I said, I will do an Istio tutorial using multiple microservices, so that you actually see how it works. So for the most part, we'll be just using one microservice. So you want to write the Istio injected is equals to enabled, like this, right? So what this does is it will allow the injection of these envoy proxies to our backend services namespace. So if I type enter, right, so if I check again, show labels, you can actually see that we now have Istio injected enabled on our namespace, right? So which means the sidecar envoy proxies, they are now injected, right? So once you have done that, the next thing that we probably want to actually look at is, let's now create our Kubernetes resources in terms of for our application. So what I'm simply going to do is, inside the root project of our project, the root folder of our project, I'm going to create a directory, and I'm going to call it k8 s for Kubernetes. And then inside this Kubernetes file, I'm going to create a file called spring native.yaml, right? So I have this defined somewhere, so I'm just going to grab it and then paste it here, right? And then I'll explain what this is. So I want to be able to create our deployment and our service components, right? So if I check in this file, what I have a definition for our deployment, right? So the metadata, to name the deployment, you simply put the tag metadata in our YAML file, and the metadata is called spring native. This is the name of my deployment. and then I'll specify the namespace. In this case, it's in the namespace called backend services, and then you need to label it, right? Because labels are important, because when you do other things like you want to be able to view metrics and other things like that Istio manages, you should have these labels defined for all your components that you have defined. Then in terms of the specifications, for my deployment, I'm only going to have one replica, which means I'm going to have one pod running for my service, and then it's going to match the label name, that is the Spring Native. And then for my container, the container name is going to be called Spring Native, and then the image, I'm going to call it Spring and then my native. So remember that Spring my native that we created from that Docker file. This is the image that we're going to inject, and the tag, we're going to tag it as latest. Then the container port is the default 8080 for our Spring project. Then the image pull policy, I've set it to never, because we want to be able to pull this image locally from our Docker image registry instead of pulling it from outside. So image pull policy, I'm going to say it never. Then the other component that I'm defining, so this was our deployment. The other one is the service, right? So the service is the one that will give us access to that Ingress will communicate to in terms of our visual service. It will communicate, it will point to this service, right? So the service is the one that will be called by our visual service. We'll discuss that shortly. So this is a service, right? So the service name is called Spring, and then I'll define the namespace for the service, and the protocol is TCP, then the port 8080, then the target port 8080, and then the selector, and then the type. So by default it's cluster IP. So the reason why I put cluster IP is I don't want it to be accessible via outside. So we want it to be sort of like an internal service, so it will have an internal cluster IP. So once you have defined your deployment, right, the next thing would literally to actually run this one, right? So if I clear my terminal, right, let's simply go ahead and apply this file. So if I say kubectl, right, so if I say kubectl and then I say apply, so to apply my resource file, apply -f, and then you specify the folder and the YAML file, right? So this will create the service and the deployment. So if I say kubectl get all inside the backend services namespace, right, I should be able to see everything created. So for the most part, we have a pod, and this pod it has failed. It says image error never pull, right? So I'll come to this shortly, but you can actually see that our services was actually created, which is a cluster IP and doesn't have an external IP because it's an internal it is an internal IP. Then we have our deployment, which is also running. Then our replica set that we defined is also running, which is one, right? One replica set. So let's talk about this pod, right? So this pod, for the most part, we're expecting that it should have at least created this pod, right? But this pod seems not to be running. So the reason why this pod is not running is because inside our Minikube Kubernetes cluster, we have a Docker registry that is already there, our image registry that is inside the Minikube, right? So it tried to pull this image inside of our Minikube, right? But inside our Minikube, our Docker registry, we don't have this image, right? This image is only available outside of our cluster. So if I say Docker images like so, you can actually see that we have this Spring, my native image, right? And this one is outside of our cluster, right? So what we simply want to do is we want to be able to point our Docker so that it points to our Minikube cluster, right? So for us to be able to use the Minikube Docker registry, you simply type Minikube. So I'm going to clear I've cleared my screen. So you simply type Minikube docker env. So this is the command that you simply type, right? So what this does is it will show you the environment variables that are pointing to our Docker registry of our Minikube cluster. So we want our Docker to be able to point to these environment variables. So for us to be able to do that, so to point your shell to Minikube Docker image Docker registry, you simply copy this command, right? So this is what you simply want to do. So you simply want to copy this command. So I'm simply going to, since we're on Minikube, but if you have your image outside from somewhere, you can remove this image pull policy to, or you can set always so that it pulls from that. So since we are demoing on Minikube, I'm simply going to point my local Docker to point to that Minikube, right? So once I run this command, the next thing that I simply want to do is I need to build the image again. So I'm simply going to say docker build. Remember that command that we use to build our native image, and I'll simply say spring, and then I'm going to take it with spring my native. So, right. So what this does is we now expect Docker, or we now expect this image to be able to be built inside our Minikube Docker registry. All right. So this will take a couple of minutes. So I'll see you shortly. All right. Now that we have finished building our native image, this image should now be built in our Minikube Docker registry. So what we simply want to do is we now want to reapply our Kubernetes files. So for example, if I say kubectl get pods, so I want to get pods in my backend services namespace, right? So initially we had this pod that was running here, but for the most part I think this pod, it had issues that he had, so we just want to redeploy this pod, right? So to redeploy it, it's fairly easy. So what I'm simply going to do here is I'm simply going to say kubectl. I want to delete the deployment. So I want to delete the deployment as well as the service as well that was created before, right? So this should delete the deployment in the service since we are simply using one file. And then I want to reapply this. Okay, so if I say kubectl get all, then I specify the namespace. Right. So if you do this, you should be able now to see our pod running at our pod running, right? So what this means is our pod is now actually running. Okay, so one more thing that should be happening is I was expecting to see the Istio label being injected at our backend service. But for some reason you don't see it, don't seem to see it. All right, so I think I've seen the issue. So if I say show labels again, you can actually see that the label that I put here, I said Istio injected, right? So it was supposed to be, when I set the label, if I can quickly get that command, when I labeled here, instead of Istio injected, it was supposed to be Istio injection enabled like this, right? So I'd made a typo here. So instead of saying Istio injection, I say Istio injection. So if I actually go ahead and show the labels again, and get the pods. So if I say kubectl get all, and then I'll simply get from our backend services. So I just want to reapply the configs again, right? So I want to delete the deployment and the service. So I'm simply going to say k8, right? And then I want to reapply it again, or I should have done rollout redeploy. That's fine. So if I reapply this and I say kubectl.pods, then I specify the namespace, which is backend services. All right. So as you can see, right now we now have 2 running pods, right? So, but if I check everything, so besides pod, the rest of everything should be just single instance running. So I have 2 pods that are running for Spring Native. Then I have 1 service, of course, and then 1 deployment and 1 replica set. So why do we have 2 pods here? So remember, when you installed Istio, we said Istio, what Istio does is the Istio control plane, the Istio D, will actually go ahead and inject Envoy proxies to our running pods as a sidecar, right? So what this means is Istio will inject an Envoy proxy that will be able to handle communication between our services in a service mesh, in a network mesh. Then it also configures things like security, as well as observability for metrics and other things like that. So if I actually go ahead and describe this pod, so if I say kubectl describe pod, right, and then I copy this pod name, right, we should be able to see our pod running, as well as our Istio container as well. So in this case, we are having 2 containers running. The other one should be for Istio, which is the sidecar. So if I describe this pod, right, and then if I, let me just go up, right? So if I go up under containers, right? So if I go under container sections, we can actually see that the first container that we have the image, right? The Spring Native image running, right? And then this is the Docker, the image ID in our Minikube Docker registry, right? But here we also have an Istio proxy, right? So this is our sidecar that was injected. So remember, we had injected Istio injection to our namespace, so which means every time we deploy a pod into this namespace, Istio will automatically inject a sidecar proxy. So this is a sidecar proxy, an Envoy proxy that was injected, right? So what this means is, if we are going to have multiple services running actually inside our Kubernetes cluster, so as long as they have sidecar injection, we'll be able to do communication, which is mesh via the mesh networking. Security will be handled if we are to configure that, as well as some metrics that will be happening within our Kubernetes cluster. So for the most part, this is how you can actually go ahead and deploy your pods and make sure that the injection is working quite well. So what we now want to look at next is, how can you actually go ahead and access our service from the outside network. So we can always access this service by port forwarding. So for example, if I say kubectl, let's say get service. So if I say get service in our backend services, and then I say kubectl, I can always port forward this. So I want to port forward the Spring Native as service, and then 8080, and then I will specify the backend. So in this, the namespace, I mean, so in this case is this one. Then I can always kill, right? So I can always HTTP. So in this case it was localhost, localhost 8080, right? And then we have /API, slash, was it customers, I think that's the endpoint that we had. So you can actually see that if you port forward the service, you can always access, right? But in this case, what we want to demonstrate is, since we've installed Istio, we want to demonstrate like how do we access our services from the outside network. So which means we want to be able to tell Istio to do some traffic routing through the Ingress gateway that we are going to configure. So see you in the next one. All right. So as I mentioned earlier, Istio by default doesn't allow traffic in or traffic outside without making any, without doing any other external configurations, right? So like what I mentioned, right? So if you say kubectl and you get everything within the Istio namespace, so it's Istio system, right? So if you try to get everything within the Istio system, we can actually see that on our we have the Ingress, right? In terms of the running pods, we have the Ingress and the Egress gateway. So the Ingress is used to route or to intercept all incoming traffic that will be coming inside of our cluster from the outside network, and then the egress is responsible for traffic going out, right? So by default, as you can see, the load balancer for our egress gateway right now is not yet configured to say if we receive any specific traffic from the outside, where does it route to, right? Also, so for the most part right now, if we try to port forward this, right, we actually see that traffic information won't go anywhere. So for us to be able to intercept that traffic, we need to be able to configure our Ingress gateway so that we actually tell it what to do, right? So we actually do it via creating something that is called gateways and virtual service, right? So what I'm simply going to do inside the K8s folder, I'm going to create another directory called Istio. So inside this Istio directory, I'm going to create a new file that is called gateway.yaml. So inside this gateway YAML, we want to actually go ahead and create our gateway. So here I've pasted my gateway that I have, right? So for the most part, the kind of this component is a gateway, and the name of this gateway is called Spring Native Gateway. And this gateway, this is important. You need to make sure that you specify the namespace to which you want this gateway to work, right? So for the most part, this gateway is going to handle all traffic that will be coming to our backend services namespace. So in this case, I'm simply going to put the namespace backend services, right? And then for the selector, remember, Istio by default, when you installed Istio, it came with this Ingress gateway. So this is what we just put here, Ingress gateway. We're going to use the default one. So you can always create all your gateways, but for the most part, I'm just going to use the default one. And then for the port, this is the enter port, which is port 80, and then the protocol is going to be HTTP. Then under hosts, for the most part, I'm just going to put all, because I don't have a valid domain. So we're just going to allow traffic even coming from localhost as a domain. So here I'm just going to leave it as asterisk, right? So this is how you actually go ahead and configure your gateway. Then after configuring your gateway, the next thing that you want to configure something that is called a virtual service. So what a virtual service does is it actually allows you to define or to prefix the actual path or the actual services that you would want Istio or the gateway to actually redirect the traffic to. So I'm going to create something that is called, I'm going to, inside that same Istio folder, I'm going to create a file called virtual service.yaml. So inside this virtual service, I've pasted this configuration for this component. So the kind is a virtual service, and the meta name, I'm just going to call it Spring Native, and then the namespace is going to be in the backend services namespace, just like what we did with our gateway. And then remember, for the gateways now, right? So initially we have a hosts, right? So for the hosts, right, we want to say if we're coming from a specific domain, this is where you put it. But for the most part, like I said, I'm just going to put all, right? So this gateway is for a specific service, right? So let's say we're in a microservice architecture, and we had so many services that we had configured, right? So which means each microservices would have its own gateway, virtual service, right? So for the most part, this one I'm just going to put all because we don't have a domain. Then under gateways, you need to make sure that you specify the same name, the name that you have given to your gateway here. So in this case, we called it Spring Native Gateway. This is the name of the gateway. So this is what we want to configure here, right? Then under this HTTP match, so we want to be able to route traffic, right? So if someone hits our domain, so let's say our domain, for example, let's say it was going to be, I don't know, yeah, so let's say it was going to be StackDev, let's say .io, right? So if a request comes from let's say portal.stackdev.io, and then someone was trying to access, let's say /API /customer. So for example, something like this, what would happen is Istio is our virtual service is now supposed to redirect that traffic to a specific service within our Kubernetes cluster. So in this case, what we're simply doing, we're simply mentioning the URL to say if someone tries to access this /API /customers, which is an endpoint that we have within our service. So if you open our Java service, if you go under controllers, we had something called API /customers. So this is what we are configuring for our virtual service. So we simply want to say, so there are a lot of things that you can do with this virtual service, but for now, let's just discuss this endpoint kind of thing. So if someone tries to access this API /customers, what we want to do is want to be able to route that traffic to a specific destination or to a specific service. So in this case, we are only routing it to a service called Spring Native, right? So here I didn't give the full name like local cluster, cluster.local. Because we're already in the same namespace. So I'm just going to call this service, which is Spring Native. So remember, if I go to Spring Native YAML, our service was called Spring Native. So this is the service name that I'm just calling. So if we hit this, we are going to hit this endpoint. So once you have set this up, what you simply want to do is we simply want to apply both files, right? So we simply want to say kubectl apply as f, and then we apply the gateway. So it's kh, and then we apply the gateway. So it was in the Istio folder, and then the gateway. So once we apply the gateway, it's supposed to be created inside our namespace, which is the backend services. So I don't need to specify this. So because we're already specifying the namespace anyway, and then we also want to apply the virtual service, right? So if I now say kubectl get all, and then I get the Istio system namespace, right? So if you do this, so if I say default, okay, yeah. So if you do this, right, you should be able to see. Yeah, so these components are the gateways. Of course, you won't see them here, but what we simply want to do is I want to port forward our Ingress gateway. That's what I want to do actually. So if I port forward, so if I say kubectl, I want to port forward this. I'm a little bit tired now, but I need to get this done. So if I say kubectl port forward, so I want to port forward the Ingress gateway, because remember we don't have any public IP, so I just want to simulate how the public IP will work. So I want to port forward this, right? So Istio system, right? So in terms of our port, I'm going to use port 8002 for my local machine, and then this one I'm going to use the default TCP port, which is port 80, like so, right? So what this means is I've bind the port 80 inside our Istio out, and then the port 8002 outside, right? So what you simply want to do is if I go back to if I try to kill that port 8002, so let's see. So if I edit my kill command and I kill 8002, boom, voila. So we should be able to see that our traffic truly it was routed to our service via the Ingress, because right now what I've just port forwarded was just the Ingress gateway, and then it created this, right? So just to show you that there's no fishy things going on. So if I delete, let me try to delete the gateway, the gateway deployment. So if I delete the gateway and the visual service, or I should have deleted one of them. It's fine. So if I delete both of them, and then I try to port forward again the Istio system, and then I try to query my endpoint, right? You can actually see that the server is actually returned a 502, right? So which means there was no path that was defined to route this incoming traffic. So like I said, Istio by default, it doesn't allow that unless if you create a gateway and a visual service. So let me just quickly go ahead and reapply these files, right? So if I reapply this one, I will reapply the visual service, right? And then I port forward my Ingress, and then I try to access the Ingress. You can actually see that our application is back up. So if you've gotten this far, congratulations guys. This is how we can actually do an end-to-end deployment of our Spring Native application to Kubernetes using Ingress Gateway as our reverse proxy. So maybe the last thing that we can actually go ahead and look at is how can you actually be able to monitor metrics, right? Who would want to monitor things like logs, how your pods are doing inside your cluster, how things are communicating, any sort of metrics data that you can think of, right? So this is something that we just want to look at. So see you in the next one. All right, so Istio comes with beautiful tools that allows us to do metrics and tracing. So as I mentioned earlier, we said Istio, when you deploy Istio and we allow Istio injection to our namespace, whenever we deploy a pod, Istio deploys or injected this Istio envoy sidecar that allows us to do things like metrics, security, service communication, and etc. Right? So Istio by default, it comes with these metrics and tracing add-ons that actually make us able sort of like to monitor and trace our services in terms of what's happening within the cluster. So it has a couple of add-ons that it comes with that includes Grafana, Prometheus, Kiali. So for the most part, Grafana is just an open source data visualization tool for metrics data. Same as Prometheus, it can monitor anything within the cluster, including memory, CPU, and other Kubernetes components. Then we also have Kiali, which actually helps you understand the structure and health of your service. mesh by monitoring traffic flow to infer the topology and report errors, right? So these add-ons, so if you remember, so if you actually go ahead and navigate to that Istio folder that we are in right now, and if I navigate to I think there was a samples. So there's a folder called add-ons, right? So inside these add-ons, you can actually see that we have this YAML file that we can actually use to install all these add-ons, right? So for example, we have Prometheus, we have Kiali, which is quite a nice tool for sort of like viewing the topology of a network, how traffic is coming and out, going out. We have Jaeger, we have Grafana, we have also these extras as well. So if I say extras, so we're not going to exhaust all of them. I just want to show you how we can install some these components. So we also have Zipkin and other things, right? So what you want to do is this Istio provides these as a metrics tools that you can actually use. You might be familiar with some of them. So what I'm simply going to do is I'm simply going to say kubectl apply -f, then I'm going to apply everything that is in this add-on folder. So what it does is it actually go ahead and provision all these metric tools within our Kubernetes cluster. So if I actually say kubectl get all within our Istio namespace, right? So if I open our Istio namespace, you can actually see that there are now a lot of things that has been provisioned, right? So besides, so if I look at our services, you can actually see that there's now a Jaeger collector, there's now a Kiali, Prometheus, tracing, Zipkin. So all these tools, right, you can actually use them to do metrics and tracing, right? So what I'm simply want to do is I want to port forward one of them or two. So I will say kubectl port forward, right? I want to port forward let's say I want to port forward Kiali. So Kiali is running at port 9 Kiali is 20,001 20,000, right? And then it's in the Istio. So remember, you need to specify the namespace. So if I port forward why can I not? It's saying it's still deploying 20,000. It's saying pod is not running. So I guess this is still deploying. So let's just give it some time. So let's see. Okay, so it seems as if it was still it's still deploying because it's now 0 out of 1. The other ones are already running. So let's try another one. Let's try Grafana. Grafana seems to be running now. So if I go to, because I can see the pods, some of them they're still starting booting up. Okay, so Kiali is still booting up, but Grafana is finished. So let's try Grafana. So let's try to port forward Grafana. And Grafana is, if I check the service, yeah, it's running on port 3000. So that's okay. So if I try Grafana 1, 2, 3. So let's try Grafana. Perfect. So if I port forward Grafana, right, let's quickly go ahead and navigate to our browser. Let's say localhost 3000. Boom, right? So I can actually see that Grafana here has been installed. So you can actually go ahead and configure some of these things, and you can actually go ahead and do your metrics and stuff. So in this tutorial, I'm not going to focus. You can always play around with this and you can always pull records and data. But like I said before, I will do a separate Istio video with a little bit more other microservices that you can actually go ahead and look at, right? So the one that I really wanted to show was Kiali. So the deployment is complete, so let's try to port forward it again. Okay, so if I navigate to my I'm already in my browser, so I've port forwarded it. So if I say localhost, it was on 20,001, so this is Kiali. So if I open my Kiali, you can actually see that we have some interesting things that you can always view, right? So if I go to graph and I specify, why is it saying my nodes are idle? Perfect. So I think, I don't know, it was still booting. But you can actually see that you can actually see, if we had so many microservices, you could see them joining and intertwining together. But these are some of the things that you can see. You can always check the applications that are running. So in this case, we have the Spring Native application. It does not have any traffic for now, but if you try to do some requests, you can see some of these graphs doing what they do best. Then you can also see that the workloads are there, and we have one workload that is currently running. Then the services, of course, it's one service that is running. So there are so many things that we can configure, and you can actually view some of the metrics data within some of these dashboards. So I know that this tutorial has already been long, guys. If you have reached this far, thank you so much for staying in tune. I hope you guys find this video helpful. So I'm looking forward to do more Kubernetes and Spring, and do microservices with Quarkers and Spring together, so that you can see the power of microservices within Kubernetes, especially cloud native development. So I hope you guys enjoyed this video. If you find this video helpful, please don't forget to like, share, and to subscribe the video. It really goes a long way. Thank you so much, guys, for sticking in. I will see you in the next one. Cheers.